Okay, so here we go. Today we're going to talk about the tables, equations, and graph revision. We're going to start that by talking about linear relationships. Remember that when we're talking about linear, one way you can recognize that, if you have a linear equation, there are no exponents. Right? So if you see a square or a cube or something like that, you know it's not linear. You know that a graph is linear if the graph is a straight line. Yeah? So. Okay? So remember, no exponents or the graph is a straight line. Right? Okay. So let's just go to the questions and look at some of them and talk about the skills that you're going to need. I'll just sit up here and talk to myself if I need to. All right. Blake receives a copy of his bank statement and finds out he is overdrawn. In other words, he has a negative amount in his bank account. He starts his savings plan. The graph below shows the amount of money he hopes to save in his account in S dollars if he follows his savings plan for N weeks. So here you have your graph. Along the bottom, you have the scale of weeks, right? Why is it in the middle here? Because he starts out where? Negative. Right. And then it goes up from there. And on the y-axis is the savings in S dollars. How much does he plan to bank each week? Rise over run. You're going to count from one point to another. So how much he plans to bank each week is the same as saying change, which is the same as the gradient. In other words, how much does his balance change is the amount that he's putting in every week. Do you agree? And all we have to do is count it as rise over what? Run. Good. So we'll just pick a point, any point on there. And so I'm going to make it a little bigger to make it easier. So if you go from there to there, it goes up to, but remember the scale. If this is 100 and this is 200,
20s.
They're counting in 20s. Yes, good. So that's up to, so that's actually an increase of 20 for every 1 week. So 20 over 1, right? Oh, we went up 2. I'm sorry. We're counting in 20s. Sorry. Very good. I did that on purpose to make sure you're paying attention. Gives you 40 over 1. So that means that each week he is banking 40 what? Dollars. Remember, if you forget the units, you are toast. Okay? So anytime they ask questions about change, remember change and gradient mean exactly the same thing. And if you have the graph, you find it. Guys. Okay. Rise over run. Okay? Count from one point to another point. Make sure they're easily identifiable points, right? You wouldn't want to count to here because that's in between the line, right? So you need to make sure you count points that are easy to find the values for. Okay. And your graph is probably going to be a little bigger than that one when you look at it. Right, let's look at the next one. Give the equation for the graph of blank savings in terms of S, the amount in his bank account, and N, the number of weeks after the start of his saving plan. Okay, so we need, in other words, we want to find the equation of this line. Now, do you remember there are 2 ways for finding the equation of a line? Put it in your calculator if you know how to do it. That's perfectly fine. You don't have to show any work. But we also use that y equals what? Mx plus b or c, the constant, where m is the what? Which we already know from the first question. And c is the same as the, anybody remember? The y-intercept. Excellent. Right? Okay. Now, so all we need to do is find those 2 points, and then we can find the equation of the line. Now, let's see, is that what they used, I hope? Okay, so he got his $40. There you are. So, the slope, the gradient we found was 40, right? So S is equal to 40 n weeks, right? Minus 200. Because the minus 200 came from where? The y-intercept. So if you have a graph and you can identify the y-intercept easily and you find the gradient, then it's simply a matter of just plugging those two numbers in. Yeah? Okay. No, what is it? Yeah. Well, I'm going to scroll up to go back to the graph. Okay? So we found the gradient, and here is the point where the line, where it starts on the y-axis, right? You just find the point on the y-axis, which is right there. Yeah, it goes up 20 for each time. Yeah, up 40 and over and to the right one. Okay. What else can you tell about this graph since it's doing that? It'll continue that way infinitely or until he stops putting money in the bank. And what else, though? It's increasing or decreasing? Increasing. There you go. Yeah, not constant. What does a constant graph look like? Flat.
A constant increase.
Yeah, but it does have a constant increase, you bet. Okay? Which in other words means it's linear. Okay? Alrighty. What's next? Blake's grandmother thinks he should be saving more. At the end of 4 weeks, she tells him that the amount he's banking out in the end of 9 weeks is $900. She will give him $50. $300. What am I? 9 weeks, $300. I'm sorry, can't read. He increases the fixed amount he saved each week from the end of week 4. Okay? And he reaches his grandmother's target of $300 in his account and banks $50 from his grandmother. He continues saving.
This is hard to say in my head.
Yeah.
Because there's no graph.
Well, we'll get there, though. He continues saving at the increased rate after $50 from his grandmother's. Describe how the graph changes from week 4 onwards. Okay? Now, and again, they give you hints. You can do this by giving equations for some parts of the graph, and you may find it helpful to sketch the graph using the grid above. Okay? Now, from weeks 4 to 9, all right, so we need to find an equation for that. So here's week 4, right here, yes? So at that point, he starts to save a new amount. Do you agree? So what we need to do is we need to find what that point is. Okay. But that's at week 4. So that means our first value is 4. And at that point, he has a negative 60, right? He's still down below having positive money yet, isn't he? It's 2 lines up from 100, so that's 60, but it's negative 60. So that's the point 4, negative 60, yes? Okay. We also know that if he changes the amount that he's going to save, it's going to also change the gradient. But he wants it to get to be at the point where he has a savings at the end of week what? At the end of week 9, he wants that, so 9 weeks needs to be at 300. Yes? So that means here, this needs to go up some. So that's going to tell us how far our gradient goes up. So look at, right now at week 9, he has, what is that? $160? Yes?
Yes.
Okay. But that needs to go up to 300. So at that point, we want it to become 300. It's hard on this graph. It's so tiny. So we need it to be up there, right? Now, it's going to be consistent, which tells you that it's going to be linear, right? So if it goes up from here, if it goes up from this point from 160 to 300, what's 300 minus 160 make? 140. So that means if it's gone up 140 there, then what else? It's gone up 140 down here too, right? So just count up. So what would that be from 60 to, so 140 minus the 60, right? So it should be at $80 there instead of where it is down here. So it's going to go up to $80. You see the logic there? If it's going to be that high at one point, just find out how much difference that is, how much higher that was than at the previous point. And because he's saving the same amount every week, it has to be linear. which means it has to be that high off the other graph for that point as well. Does that make sense to you? Okay, so our new line is up here. So that means that it was here, jumped up, and it's really not a line, it's dots. Why is it dots? He's only saving once a week, right? So it shouldn't be lines like I'm drawing here. It should be dots. Okay? And be careful about that. They do make that distinction. Okay? So it's just going up the same fixed amount all the time. Then what happens at week 5 when he hits the $300 goal? He gets 50. So it's going to jump right up on that same week, straight up by $50, right? So from here, it's going to go up $50, which is really fun in this graph because this graph is done in 20s. So in the middle of a piece, right? And then he continues that level of savings past that point. So that means it's going up the same amount. So what we need to do is find the slope of this to find out how much it's going so that we can then count rise over run, rise over run, rise over run, and put some more dots in. Does that make sense? Okay. So this one's not going to be linear everywhere. It's going to be linear with some jumps in it. Okay. So let's look. Maybe they gave us the graph, the completed graph. No, they're jerks. Okay. Now. Right, and then from there you can then do the same thing with the finding the equation of the line, or you can say that the graph is parallel to the last one because he's still saving $68 per week. So that's his new slope. $68 is his new week. $68 is his new slope if you counted it out after 9 weeks. Okay.
Wait, shouldn't it be like 450? 9 times 5?
No, don't do 9 times 5 because you got to remember he already had some. He was already going up some, and now he's going up more.
This is how those go.
Okay. Yes.